first project on the Victor in its new location over here in the corner. I found a piece of 1 3/16 stress proof material. This is free machining, and it's good strong material, so it's easy to cut. We're going to use a 3-jaw chuck. We'll drill our hole. That'll be our clearance hole for a 1/4 inch bolt down the middle, and then we'll turn it as needed and part it off, and then what we'll do is we'll set it back up, and I'll do the counterbore for the bushing that's supposed to fit inside of it. I'm going to use a high-speed tool bit, so I'm going to use my Armstrong holder, and I went ahead and I ground up a fresh turning tool, just a general purpose turning tool bit out of a piece of Rex 95, and we'll give this a try, and we'll start using that. It sticks out more than what I would like to, but I hate cutting those off unless I need, so I'm just going to go with it. For light duty turning like this, it's going to be good. There we go. Just adjusting the center there. You might be wondering how you can accurately measure those counterbores down in there. Now, one way that you could do it is if you had some pin gauges. Those are excellent for jobs like that. Alright, I've got another way. Since I don't have any pin gauges that go up to 1 inch, I'm going to be using my Starrett number 700. This is 200 to 1 inch. 200 thousandths to 1 inch, so it's, you know, like a 0 to 1 inch mic. This was my granddad's. Matter of fact, that's his initials right there. So we're going to use this. Now I've already verified these. You can go with another 1 inch mic that you know is on size, and you can verify the outside. And you use these just like you would like a vernier caliper. Try to get it out of here without bumping it. So it looks like we've got, it's going to be, that's 759 thousandths, and then we'll let me move out, and then we'll check it with the other micrometer. Alright, so I'm going to take my 0 to 1, and we're going to go ahead and check it there. That feels like it right there. So it looks like there could be 2, maybe 3/10 difference total. We got our measurements. I'll go ahead and get back on turning this. So we're at 980, but I'm going to have to go ahead and turn this area down some before I can get my mic in there to measure this little area accurately. So we're at 980. We're going to take 2 more cuts. Alright, so I'll go ahead and get this larger diameter finished out. We're going to finish it at 9/18. Let's see if I hit my target. 9/18.5. So that's perfect. It won't take but just a touch with either a file or some emery, and that'll take that right where I want it. Okay, I'm at 765. Take 4.5 thousandths on the dial, and let's hope that I'm there. Come up to our 0. Okay, go in 2 thousandths on the face. Face it back. And hopefully that's going to be our diameters to give us a slight interference fit in the hole. Okay, there we go. 760.5. Swap out our tool bit there for a chamfering tool. And we want to break those corners. So we're going to use that 1/4 inch stubby drill there to drill our hole. It is a trying to find its center there. It is a 1/4 inch bolt that goes through it. All right, so we're gonna give it some clearance with a 281 drill. Some of you guys probably wondering why I'm not using any cutting oil. A lot of times on this stress proof, you know, for this small a bit of work that we're doing, cutting oil really isn't necessary. I mean, you can, it's going to help it cut a little better, but stress proof is a pretty free machining material, and for the most part it does pretty good. So really no need for cutting oil. You can deburr those holes with your Noga. That's all it takes. So we're going to go ahead and part that thing off. I've got it polished down to our sizes that we want. I want to point out I'm using a high-speed steel tool parting blade there. It's 1/8 wide. Miking it is actually 0.128 inches wide. So I touched off on the very end of it, and we moved it down 378 thousandths, and that should give us our finished parting length there. So parting usually wants oil whenever you do that, so we are going to use a little bit of cutting oil on that. And I do have an angle ground on the end of that blade. Now we're just going to go in a bit. I'm going to back out and go ahead and file that sharp corner off. Stick our catcher rod in there. There it is. So we're not done yet. We've still got to chuck this back up. And we're going to come in on this side and counterbore it for our pin that fits in there. Alright, there's our bushing there. This is our pin that's going to fit in it like that, so I need to counterbore it. We're going to counterbore it 3/16 deep up to this size. And what's surprising me, this is 14 millimeter. It's an old Harley engine, so I don't know why this would be 14 millimeter, but that's what it is. So, but miking it with the mic, what we're going to do is we're going to finish this bore at 0.555, and that should give it about a half dowel clearance to go down in there. Alright, so I've got the hard-inch collet chuck set up with a 3/4 collet, and this will fit. Make sure there's no fuzz on it right there, get rid of them burrs. And I'm using a very small boring bar, but this will allow me to get up in that 1/4 inch hole and do our little counter bore. So hopefully it'll work pretty good here. Alright, let's get going. Touching off on our face, and I'm going to set the dial here. $50,000ths, and it works, so let's do another 50. You can see it bend down. That's okay. If I needed to, I could go in there right now. I have some small carbide insert bars, but none of them was small enough to go in a 1/4 inch hole. But that's going to give us what we need right there. Alright, take another 50. Alright, I'm going to get my mics and I'm going to start doing some measuring. I'm going to use my general telescoping gauge. This one is under, I believe it's 1/4 to 1/2 inch. Now, in the past, I had a lot of people comment on how you're supposed to get an accurate measurement with these things with a square end, when in fact they're not square end, they're radiused. They're radiused properly so that you can get your minimum diameter that you need. So just stick it in there. Snug it up, push it down, and then mic over it. I like to rock it back and forth so that it's touching. And that puts us at 480, 483. Okay, still got a little bit to go. I should be getting down to my finished cut right here. I've been sneaking up on it. I should have about 6/1000ths, I believe, to come out of this thing. 5.5. So I'm going to go for it because I just split the cut. I just took 5/1000ths, and I am using some cutting oil now. I'm going to go ahead and touch the face. 2/1000ths. So this is a good job for pin gauges. And I have pin gauges from a 1/16 to a 1/4, I'm sorry, from 1/16 to 1/2. And then I do have a set that goes like from 3/4 to 7/8. But you can use those pin gauges that are like in 1/1000 increments to check holes like this, you know, instead of using telescope gauges or micrometers. So it looks like right where I want it, a few tenths under. I'm going to double check it, so I can probably stick some emery in there and polish it out of there. Yeah, I'm like right on it. Right on it. Instead of risking cutting it too big, probably just go ahead and polish it out of there. Now that may not do it, but we're going to give it a shot and see. I think that did do it. It's a really close fit though. Oh yeah. It's super close. It's trying to go in there. You can see I'm wiggling it. So that's definitely where we need to be, but I don't want to get it locked in there. So see that? We're going to go ahead and pop it out of there, and we're going to leave that fit right where it's at. Before I attempt to press the bushing in there, I'm going to use this Noga straight bladed scraper right here and try to very, very gently go in there and lightly deburr that edge where the bushing needs to start in there so that it's not a sharp edge. Alright, so I'm going to have to move the camera, but I wanted to do just enough to kind of show you. Just like that. I'm going to have to kind of come around like that and get in the way, but that's what we're going to use right there. I'm going to give a little shot with my solvent cleaner right here. Just to make sure everything's clean, and this stuff dries pretty fast as well. And I'm going to do the same thing to the bushing. We'll spray it a little bit, make sure it's good and clean as well. Alright, we're going to go ahead and get it in there. So I'm going to use just a little bit of my 680 Loctite. This is good stuff right here. Just want a little bit. Pardon my hand. Alright, I think that's it. Alright, here it is. Alright, it's going down in there. I can feel it. Alright, that's going to work. So he can pull that in there with the screw or bump it in there, whatever he wants to do. We're going to leave it. We're going to leave it about like that. I just got it started in there. I'm going to see if the cover plate will line up on it now. All right, here's our cover plate, and let's see if it'll line up. at that. It's in it. Looks like we have success. All right, man. Very nice. Let's see if I can get that back off. There we go. Okay. There we go. All right, one last thing I'm going to do. I want to go get my depth mic and measure from here down to that face and see how close I am to what I had measured the original face at. So when I took the original measurement, it was almost like that surface was slightly sloped. So when I took it like in the best place that I could to split the difference, and I was getting 1.2 inches, 1.200. That's what I wrote down. So let's see what I'm getting now. I'm getting 204. So I'm actually 4 thousandths deeper than what I had originally mic'd that at. All right, guys, we got another one done, and I believe it was a complete success, and I'm happy with the way it turned out. Everything lined up. I didn't have any problems. Everything went my way. So I'm glad to get this one done because I wanted to get this one finished up so that I can get back on to my shaper project. I got some parts I want to get started on for that. But good little project for the channel there, showing you some different techniques on the mill and the lathe, you know. And another reason why it pays to have an assortment of different tools, you know, around the shop. This is why you have many different types of measuring tools. It's not necessarily, you know, this isn't something that you would use every day, but there comes a time when you actually need a tool like this to do a certain measurement, you know, so it's good to have that kind of stuff. But there we go. I'm going to sign off and let them know that this is done. And I hope you guys enjoyed watching this video, and it was good to get another project done in the shop. It's been a little while, and I look forward to continuing to do that for you here on the channel. All right, see you guys next time.